streaming. Hey, ik ben live.
Kan mij de link sturen?
Ja. 1 seconde. Dit zou moeten werken.
Yes, cool.
Hi everyone, who's just joining in. Welcome to the stream. Shema, can you also test if the stream is working for you?
Yes, let me check quickly.
Or do I still have to go live here?
1 second. I'm just sending it to Lilia. Okay, and now I'm gonna try it myself.
Not seeing anyone in the chat. That's suspicious.
Yeah, the link has to ship, but I get something else. No, this is not the correct one. Nee, deze werkt niet.
Die werkt niet.
Nee, it's not the one.
Oh well, even kijken.
Kan je nergens zien? Kan je hem niet delen of zo? Dat is raar. Wacht even hoor. 1 moment. Ik ga kijken of ik het misschien zo gewoon kan zien appearen. Second. Oh, wacht. I think I got it. Oh, yes.
Hij werkt, maar hij staat
Ja,
volgens mij
ik
private.
heb
Dus
hem
alleen
wel.
mensen met de link kunnen zien. Is dat de bedoeling?
Huh?
Maar de stream werkt nu, of?
Yeah, the stream is fine now. I sent it in the first use group. Lilia is now gonna put an announcement. And then
privacy is also on public, so that's good. Okay, good.
Yeah, so people should slowly start joining. Right now there's only 1 viewer.
Hey, Misha, Paul.
Oh, now we have 18 people.
We have people joining, this is good. Welcome everyone. Welcome to the stream. I'm currently looking at my own face with a lot of delay, which is very confusing.
Yeah, I wanted to say there's a lot of delay. What you
Oh, you can't hear me, Quantum? Can people please let me know if that is something with Quantum's connection or with mine? Oh, that's unfortunate. Let me see if I can try to fix that. Okay, Sheba, can you maybe lower your volume? Oh yeah, okay. Because I think some people watching the stream hear you a lot louder than they hear me.
Yeah, I muted myself already. Sorry.
Okay, but also for if you're passing me questions, can you lower your sound a bit?
Do I lower my sound on the Discord server or what?
Yeah, I think you can, or you can lower the sound of your microphone directly. Wait, actually, I should do that.
Yeah, I was already confused.
Don't mind me. Okay, say something.
Do you hear me now?
Yeah, okay.
I
Put
mean,
your bit louder
better.
because otherwise
Okay.
I can't hear you that well. Okay, yeah. I think this should be.
So is this good?
Yeah, I think this should be good.
Okay, cool. Guys, whenever you have questions, just type them. I will forward them to Olaf.
Yeah, how many people are watching now, Shema? Uh,
I see
38?
39.
Ah, right. Okay. I think I'll wait for a bit longer and then I'll start the tutorial. And if people already have questions, put them in the YouTube chat and we'll get to them.
Olaf, how long do you think it will take?
The stream will probably take about an hour, maybe less if we get to it quickly, maybe more if we get stuck on some things. Also depends on the number of questions I get and how long it takes to answer those.
Yeah. Okay.
Afterwards, I will also be available on the Cognac Discord for further questions.
Someone says, Jesus, my ear. Someone is
Yeah,
starting
I
to
think
speak
you might
language.
still be very loud for them. Let me see if I can configure this. Can you say something again? Okay, so I lowered the desktop audio on my stream right now, so I think that should maybe help. Like, it's hard to get these. Okay, are those heroes at the same level? Oh, well. Okay, I'll just leave it like this. If it's really a big problem, let us know in the chat, and if enough people.
I will mute myself anyway, so you guys won't be disturbed by me.
Yeah, Mirta, I know I've already made my microphone as sensitive as it can be. I'm not really sure why it isn't picking us up as well as it should be. But I'll try to maybe talk a bit closer and a bit louder.
Olaf, now someone says that I am not.
All
Um,
right. Well, I'll put you a bit louder again. Okay, let's get started. I think. Um, Again, Shema, if there's like a lot of questions coming in, just interrupt me once I'm about to move to the next section, and I'll answer questions before that. Um, or if there's technical difficulties, also obviously let me know. Okay. So first things first. Um, One of the things we started with this programming 2 course was classes and how to make your own classes and how to declare instances of classes and make objects and work with those. Uh, so in a way, classes are a lot like lists or arrays in that they are collections of data, of objects. Um, the difference between classes and arrays is that with classes, you can have different kinds of data, different functions, different fields, different parameters inside of the same class, while with lists or array lists or with arrays, you can have only one type of object. So you can have, for example, only an array of strings or only a with classes, this is not the case. You can have multiple things inside of one class. For example, if we go to this class we created here, article, uh, this article contains multiple fields. It has an ID, which is an integer that distinguishes it from other articles. It has a name, and it has an integer that gives information of how many of that article we have in stock. Now, another difference between articles and items inside of an array is that the fields of the um, class are always referenced by name. So if you want to get the ID from this article, you have to specifically mention this ID or call a function that has the ID specified in it. And similarly, if you need to know the name, well, then you call it by name. While when you are using an array, um, you generally call that by number. So you would say my array, and then if you want the fourth element, you say, okay, I want a tree from that array, and then it will give you that specific one. Well, in classes, it works differently. First of all, how do we create a class? Well, just like with um, usual types, so like with integers or with strings, you can declare a class without assigning any value to it. And you can do that simply by giving the type article, which is the class we created before, and the name. So over here we have declared uh, an article which we have called book. We can also immediately assign a value to it. So let's say we want to have this pencil, and we say, okay, we create this new article. So this pencil already has a bunch of values given to it. Now, all of these values will be default since we haven't specified what any of them will be. But we can assign those later on. So for example, if we say pencil in stock and we set that to a value, say 1000, then inside of the class article, uh, it will look at the field in stock and it will assign a value to that. So right now, first we create this object, this pencil. Then we say for this specific object, we want the stock to be 1000, and then the value of that is set to 1000. Now notice this doesn't mean that for any article that corresponds to that class, this will be the same thing. We can, for example, create a different article. So let's say a pen. And the value of that will not be the same as the value of pencil. It will have its own set of all of these fields. So we can say that for the pens, we have a stock of 250, let's say. So again, these keep their own collections of these same attributes, which we can manipulate through this.
Olaf,
Yes.
can I interrupt with two questions?
Sure.
So one question is, so just adding article book will not assign the value of in stock to 0? That's the first question.
Yes. This will mean article book will simply be null. There will be no book. But we are declaring that inside of this class, inside of our PTO0 structures, we want to have this thing book.
Okay. And the other question from Joe Fasta is, what is the difference between article book and article book is new article?
Yes, so the difference between just declaring a value and assigning a value to it is basically the declaration just says, hey, inside of this scope, so inside of this class, want to have this value, this book. While over here we are also saying, okay, and I want to create a pencil. So, for example, if we set book in stock, we couldn't do this because the book isn't an object yet. We've just said, hey, we want to make this an object at some point. So what would that look like in practice? Well, let's say we had some function somewhere in our code, and then we said inside of that function, book is equal to a new article, or some other thing that will actually assign values to it. And then over here, it would actually create an object that is passed to that book, but the scope of book will still be class-wide. So inside of the entire class, we will be able to call the article book.
All right.
So that's the.
And then one more question.
Sure.
And that is from Laura, and she asks, do we need to know how to make our own class?
Yes, you need to know insofar as that the only thing you need to know is how to make your own class to this extent. You don't need to know how to properly pass values between them or how to do. You can just say, okay, so this would be a good example of a class that you might need to create. So just having a name and then have some attributes inside of it. So, but all of these will be given to you probably. So basically, let's say they might give you an example of, hey, we want to have something which contains a student and something else, and then you have to know that, okay, then I have to create my own class that I call student, and that I give the following attributes. And the only thing you have to do for these attributes is to have their type as well as their name. So you don't need to know how to do this properly. That you will learn in object-oriented programming. But they might ask you like this kind of simple question about that on the test.
There are more questions incoming. One is, so it's more of a scope thing to declare book?
Yes, it is a scope thing.
Okay.
Declarations are always a scope thing because like without any assignment, there isn't actually anything you can do with the object. So it's purely about saying, okay, this is the scope that I want this object to be.
Yes, and there is another question from Robin, and this question is, if you initialize it like article book is new article and then brackets, punt comma, are the ID, name, and in stock all 0/null?
Yes, that is what they will be. And like in OOP, so object-oriented programming, you will learn how to directly assign values to those once you create something, but that's not something you have to know yet.
Okay, that's cool.
Yeah, I think I'll move on now to the. Oh yeah, right. So you can make an array of objects just like you can make an array of primitive types. So remember, the syntax for making an array is first giving the type of each object inside of it and then giving these square brackets. So if you want to make an array of strings, you would say, well, string square brackets because it's an array, then the name of the array, and then give new string and then a length. And similarly, you can make an array of objects which you have defined yourself. So let's say I want to make a list of articles, or an array in this case. Then I say, okay, the type is article. This is an array. The name is, well, shop in this case. And I can again put a new of type article and then give the length. Similarly, we can make an array list of articles by saying array list, the type, these pointy brackets being that you specify type for something. We'll see more on that later. Article, name, and again we make a new array list. Over here you don't have to specify the type because it's implicit by this, but you can put it there for if it helps you. And another thing to realize with these objects is that you can put a lot of them inside of each other. So as an example, I've made this class doghouse, which has a two fields, dog and occupied. And the dog is again a class that we ourselves have created. So then you can look at the dog, and that again has some fields, and you can keep going on and on like this, like making this hierarchy of objects that contain other objects. So this date of birth might, for example, be split again between years, months, and days, and then those months might be an enumerated type that have some specific values. So you can get as creative as you want with this. You can like make all of these fields inside of classes that themselves also contain fields.
Another question.
Yeah, sure.
For array list initialization, do the second pelches, I don't know how you call them in English, need to be filled with a type?
No, they do not, but only because you've already defined the type over here. So you can leave this out because any array list that has this type, but this is basically shorthand. You can also, but you can also put this in here, and it will make no difference. Oh,
And the other question is, do the variables in the class need to have the public in front of them?
They do if you want to directly call them from another class. So I can say pencil.instock because it's a public type. If it wasn't a public type, then I couldn't say this because it's not reachable from there. And later on, you will learn in OOP how to work with those when they aren't a public type.
Okay, thank you.
Let's move on to the next subject, which is generic types. So sometimes you want to pass a function or a class, but you don't know what type there will be inside of that function. And in those cases, you use generic functions or generic classes. And in that case, you give this extra thing for the function that's basically a thing that says, hey, uh, there's some custom type inside of this function. So you can give this your own name. It's convention to just use a capital T, but if you want to call it something else, then feel free. And this thing goes between the scope of the function, so between this part and between the return value. So this returns void, and you basically just put a T over there. And that means, okay, inside of this function, there's going to be some type that will be different depending on circumstances. Now, for example, over here, a parameter is passed, which is an array of type T. And one thing in which you have used this is where you wanted to sort arrays, but you didn't know what the type of thing was that was inside of the array. And for that, you can use a specific type. And that's the comparable type. And what this basically means is that you look at the subsection of objects that can be compared to each other. So this means this function has some type that can be different that extends the comparable object. So that is a comparable object. So that can be compared to other objects. So what this basically means is that any object that can be compared to another object can be T. So, for example, an integer would fall under T, a string would fall under T because there's ways in which you can compare strings. And the way this is implemented in Java is that the things that extend comparable, they all implement this compare to function, which takes a different implementation of the same object. So let's say you have one article class and you have another article class, and it compares those two together, and it returns some integer based on which one is larger. And so any type that implements that can be sorted and can be applied to this comparable type.
Olaf, question. There are a few questions. The first is from Laura, and she asks, what does extend mean again?
Extend means that there's this class comparable, and it has some rules that you have to follow, and the type inside of this function extends that class, so it has to follow those rules. And in this case, the only rule it has to follow is that it has to have the compare to function. So let's say we wanted to make article comparable, then we could go here, say, okay, article. Oh wait, implement it actually. So this article implements comparable, then it will give an error because hey, it doesn't follow all the rules of comparable. And then you can say, okay, I want to implement the methods that correspond to that. And then you have this compare to method here. And now article is comparable because you can compare it to other articles with the compare to function.
All right. Another question is from Paul, and he asks, do we need to know how to edit the comparable operator on custom classes for the test?
You will possibly have to know how to like give the signature for this and maybe even implement it. But there won't be any like super complex stuff you have to do with it, probably. But like don't make the tests. Anything that's in the syllabus could be in the test, but I think it's likely that it will basically be give the signature, do something.
Okay. And Lara is asking, and do the compared objects have to be the same of the same type?
Not necessarily, but often for the things you will be implementing, it will be the case that they are the same type.
Okay. 1 second, sorry. Okay. And another question is, in this case, you have an array of type t as a parameter.
Mm-hmm.
So that means that this function will also work with an array of a comparable type?
Yes, exactly. So you could pass this function with, let's say, an array of integers.
Okay.
And then it would work on that function.
Cool. And Yes is asking, is this only possible with array data types?
No, definitely not. Like it's very common for array data types because those will often contain many of the same thing which you want to do something with. But it's also possible to just directly have t over here, or to have, for example, an array list with type t. So there are multiple ways to do this.
Okay, and CW is asking, do we need to know how to make a class comparable, like how to write that code?
I'm not sure. I think you should. I don't think it will be on the test. That's the short answer. The long answer is yes, because it's in the syllabus. And the thing that they might ask you is, well, if you do have to know how to make a comparable class, then just know that you have to put the compare to function in there, and that it has to return a negative number if the object is bigger than the other object, and a positive number if it's smaller than the other object.
Okay, 2 more questions. One is, do you need to know constructors for the exam, or do you not need to know that yet?
No, constructors are not part of the programming 2 course.
Yeah, I thought so. And the last question is from Mirte, and she asks, do you use T only when you want to compare 2 things?
No, but in this course, yes. So T just means, hey, I want this type to be different under different circumstances. And for comparing different objects, this is, very useful if you want to, for example, sort an array, but it's definitely not the only situation in which you can use it. I think I'll move on to sorting methods now. So
Yeah, exactly.
I'll give a brief recap of the three basic sorting methods that you covered. So insertion sort, selection sort, and bubble sort. So let's start with insertion sort. So let's say we have some array of integers. So let's call them 5, 6, 2, 9, 1. What insertion sort does it goes from one side to the other side of the array or the array list or whatever object you're trying to sort. And it continually picks out elements and inserts them in some part that's already sorted. So let's say it looks at this array. It starts on the left. It looks at the first element, inserts that because it's the only element so far inserted. Then it keeps track of the position where it's at. So right now, this is the only one in the sorted part. Then it looks at the next one. So the 6 over here, it takes that out and inserts it in the sorted part. Then it looks at the next one, takes this one out, inserts it in the sorted part, and it continually does this. So first it loops over the unsorted part, so it goes through these objects one by one, and each time it takes one, it loops over the sorted part, and once it gets to the position where it needs to be, it puts the element over there. So this 9 it would take out and go through here. It looks over here. 9 is larger than 2. 9 is also larger than 5. 9 is also larger than 6. So it inserts it over here. And then finally it takes out this 1. Goes over here. Looks okay. 1 is larger. 2 is larger than 1. So it can insert it over here. And that's how insertion sort works. So it continually takes elements and inserts them at the right position in the sorted part so far. Then we have selection sort, which basically does this a bit differently. Insertion sort goes through the entire list and looks at, okay, what object is the smallest or the largest, and it will put that in the sorted part. So let's say it goes small to large. It will go over this entire list. Look over here, this which one is the smallest. In this case, this would be 1. It takes that one out, puts it in the sorted part, goes again over the entire list, looking which one is the smallest, which in this case would be 3. Takes that one, puts it in the sorted part, loops over the unsorted list, takes out an element, puts it down, takes out an element, puts it down. And then finally we have bubble sort, which works a bit differently than the other ones in that it doesn't really keep a specific sorted section. It just goes over the list until it's sorted. So what it does, it looks at the first 2 elements. It looks if those specific ones are in the right order. If not, it swaps them around. Looks at the next 2 elements, looks if those are in the right order. If not, swaps them around. And it keeps going like this until it gets to a point where they are in the right order. Then over here. And that will look at the next 2 elements again. So it goes through the entire list, looks at each 2 adjacent ones and swaps them if they aren't in the right order. Then once it gets to the end, it starts over. So it again looks at these, are these sorted? That looks at these, those are in the right order. Then it looks at these. We'll swap these around, swap these around. And let's say at some point it loops over a few more times, and then one gets to the beginning. And now it loops over it one more time, and then it finds out that it's sorted, so it finishes. So these are three very basic sorting algorithms that you have to know about and have to handle. How would you actually implement these using arrays and ArrayLists? Well, you've basically done that in one of the assignments already. For insertion sort, the idea is the following. You keep track of where you are using some integer, let's say I call that I. And that's basically the demarcation line between the sorted and the unsorted part. Then you loop over the unsorted part. So you increase I by 1, take the next element out, and loop over the sorted part and put it in there somewhere. With selection sort, the idea is that you go through, again, keep track of where you are in the sorted, unsorted thingy. Take an element from the unsorted part, so loop through the unsorted part and put it at the right position in the sorted part, and keep going like that until the entire thing is sorted. And for bubble sort, it's basically what you would think. It's going through the list, swapping elements if they are not in the right order, and finally checking if the list is currently sorted. So that's a basic idea of these sorting algorithms. Any questions on this, Shema? Shema? Okay. Well, okay. I'll just move on to the next part, and if there are questions in a bit, then I'm sure they'll let me know. So yeah, let's look at ArrayList in a bit more depth. So ArrayLists work very similarly to arrays. They're basically just arrays with more functionality and a few other differences that I'll get to in a bit. So how do we start an array list? Well, we can declare them in the following way. You say array list, the type of the array list. Then you give the type of its elements. So in this case, it would be an array list of strings. Then you give the name of the array list. So I've called this one names, but you can call it anything you want. They say new. This because the array list is an object, just like any other object that you can create. And you give array list, give the pointy brackets to make clear that it has a specific type. And then you give these brackets just because that's how you call a new object. Then how do we interact with the array list? Well, let's say we want to add some characters to an array list of characters. Well, we can use the .add function, and unlike with arrays, which have a specific length, so you could say int int array array new int ArrayLists don't have this, so they don't have this specifier of a specific length. ArrayLists just start at length 0, and whenever you add an element, their length also increases. So let's say we have this ArrayList, my list. It starts empty. Then we add an element to it, the n character, and now it has size 1. Then you add another character to it. Now it has size 2. Then you add another character to it, and it has size 3. So you can just do this, and it won't mess anything up. It just has a flexible length. Then, unlike with arrays again, you can't just say, okay, from my list, I want the first object. Instead, you have to call methods on it. And how do you do this? Well, you can use the .get method to get a specific element from the list. So this basically just means, oh, I want to get the value at position 1. So in this case, that would be the O over here. And it will retrieve that from the list and put it over here. So this line would print O. Then there are some other functions which are very useful. There's the .size function, which returns an integer, the size of the list. And again, that size can change depending on when elements are removed or added. There's the .set method, which changes the value of a specific element. So in this case, my list .set2 would look at the third element of the list, which would be the W. So it would change this NOW to NOT. Similarly, you can add elements at specific indexes. So over here, you first give the index, then you give the value to put on that position, and then it will put it on that position. So since the list currently looks like this, OT, the K will be added at index 0, so over here, and everything else will be shifted to the right. And similarly, if we made this index 1, then it would be added at index 1, and everything else would be shifted to the right. We can also remove elements. So if we wanted to remove the element that's indexed 0, then that's removed, and everything again shifts. So the positions of elements in an array list are not constant. So they change depending on when elements are removed or added to the list. So be careful of that when you use this .get method, because you might think you are calling the correct position, but everything might have shifted depending on what elements have been added or removed from the list. And because of that, sometimes it might be better to use the .get method in a different way. You can also give a specific element from the list. So let's say I wanted to get the O from this list. Then it would get that specific element, the first instance of that specific element from the list. Now, with characters, that's not specifically useful because, well, if you have this O already, then why would you want to get it from the list? But let's say you have a list of objects, then you might want to use this kind of thing.
Okay, brief interruption again.
Yes.
First of all, sorry, I had to miss it because I got a call. Okay. Questions from the previous thing were, like the main question was, do we need to know the exact code for the sorting algorithms, or do we just need to understand it? That's one question.
For a lot of these, will this be on the exam questions? The answer is, I don't know. Like, I don't make the exams. What I will say though is that the generally, the practice exams on Brightspace are a very good indication of what kind of questions will be on the exam. So if stuff is significantly more complex than the things that are handled on those tests, then generally they will not be on the exam. But I can't specifically say no, this thing won't be on the exam because I don't know.
Yeah, exactly. And heap sorts is also part of the exam, right?
Yes, I think you need to generally know how heap sort works, but likely they will give you some kind of prompt on the exam to like check your memory and say like, hey, remember this. This is heap sort. Now do something with it.
Yeah, exactly. Okay, then questions about this part. Laura is asking, will the code Olaf is using here be put somewhere online as a sort of summary we could use?
I can share that. I'm sure Shema can take care of that.
Yeah, that will be fine. I'll make it happen. Then CW asks, can you explain how you can use the dot set with only one parameter? Like what exactly happens then?
Oh yeah, sure. Wait, can you do that? I'm not actually sure if that's something you can do. Um, there might be some implementation of that. No, it will give an error. Um, like dot set just means change an element of a specific position to a different value. So you need to give both the position that you want to change. So in this case, I want to change the element at the second position, and I want to change it to this value, this t. Um, so things that you can use with one parameter is the dot add thing, which will by default, if you don't say anything, add an element at the end of the list. So for example, over here, it will first add this n and then this o, so the n will be in front of the o. But the dot set one changes an element, so you need to specify the position that you want to change.
Okay, that's clear. And then Jesse asks, if you remove, for example, the last element of an array list, then does the size decrease or will a null/0 take the place of the removed element?
No, the size will decrease. It's different in that regard to arrays. Um, I actually think I have a thing on that. Yeah, over here. Okay. So arrays have a fixed size. Array lists do not, which is something that's like useful to remember. If you remove an element from an array, I don't think you even got the method for that, but anyway, if you do that, it will simply leave a 0 behind there because they always have a fixed size. And another difference between arrays and array lists is that arrays can work with primitives. So, for example, you can make an array of integers like this, but you can't do this with array lists. So you can't say array list int because the array list is a specific object that has to do some logic on things, and it can't do that with primitive types. So instead, for arrays, there are some classes that basically replace these types. So, for example, you have the integer class, which is basically just an int, but you can use it with these kind of objects. So, with array list, and with some other things that do similar things. And arrays have slightly faster access. So if you're super focused on like um, optimizing the speed of some program, then you might want to use arrays. But generally, it's not that big of an issue.
Okay, I think those were all the questions. Oh no, wait, one more question from Jessa, and it is, what is the replacement for a string in an array list?
The replacement for a string. Oh yeah, interesting thing about strings, they are already not a primitive type. Strings are an implementation that's basically a list of characters. So they do have this. That's also why you call them with the capital letter string instead of with a small letter like int. So strings you can use in array lists, and that's also why they have these methods like what is it compared to and They also have methods like char add and these kind of things. So strings are actually not primitive types.
Yeah, I think that's clear. Thank you.
Okay. Let's move to the next section, which is complexity. Okay, so complexity, um, it's something that a lot of people tend to find difficult, um, and something important to. Well, this list might seem a bit overwhelming, but it's really not. It's like it's just a few rules that you have to keep in mind when you're judging the complexity of a program. So what does complexity actually mean? What is the big O notation and what does it signify? Well, complexity is basically some measure that specifies um, how much um, the runtime of a program or the like um, time that it takes to compute something is affected by the size of the input. So if you have a linear complexity like big O notation n, then if the for large enough inputs, then if the input gets twice as large, then the runtime will also get twice as large. And similarly, if you have um, uh, a program of runtime n squared, then if the input size gets twice as large, then the program will run n squared times as slow. So that's basically the idea of it. And I think keeping that in mind, so this idea that it is about like how much the time scales with very, very, very large inputs will be useful in like understanding some of the other things that I'm about to discuss. Um, so first things first, functions uh, without any scaling repetitions or anything that's dependent on the size of the input will have a complexity of O1. So what does that mean? Well, that means that anywhere where there isn't a loop or something that gets longer and longer depending on the input that it takes, then the complexity of that is 1. It doesn't change. Um, so let's say we have some function over here. And it does something. So let's say it prints some stuff. And maybe it also changes some values. And it does something with those. But it never loops, or it never calls other functions, or it never does anything that doesn't scale with anything. Then the complexity of that is always O1. Always. Now, when do complexities actually get higher? Well, that happens when, for example, there's a loop over something. So let's say this function takes a string as parameter. And it does something for each thing inside of that string. So let's say so for example, over here, we loop through all of the characters inside of the string. So let's say we want to print these on a separate line. Then what will the complexity here be? Well, we have a loop over here, and that loop scales depending on the length of the string. Like if you have a string that's very, 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 very long, then it will take longer for this function to execute, right? Because, well, it needs to go through more of these characters to print. So the complexity of this will be O n. Why? Well, if this length of the string gets twice as large, then it will take twice as large to twice as many times to go through this loop before the thing is printed. So when this one is scaled to the power of 2, then similarly, this will also take twice as long. So this is why this is complexity n. And with n being the length of the string. And similarly, you could have an array over here, and it would be the length of the array if it loops through all of the characters inside of that. Now, let's say we have something else. So we do something with the characters of this string, but we also want to compare them to all of the other characters of this string. So we again loop through all of the characters inside of the string. Oh, I need to call this something else because I is already in use. And I want to do something with it over here. Well, it's not really important what. But what will the complexity of this be? Well, the thing with nested loops or with functions that call other functions is that you have to take the complexity of the inner part, so of this part, and multiply it with the complexity of the outer part. So over here, we have a loop, which we know has complexity n, because it's basically the same as the loop we had before over here. And that loop itself is also executed n times, or as many times as the length of the string. So in this case, the complexity will be O n times n, and n times n is equal to n squared. So this is how these complexities can grow to be larger when you have loops inside of loops, or when you have loops calling other functions. For example, let's say this function let's say this function was inside of another let's say this loop was inside of another function. So you had this other method over here, which is called from this loop. Well, then the complexity will also be n squared, because the complexity of this function, this extracted function that we put over here, will be complexity n.
Can I interrupt this question?
Yes. Wait. Let me actually first get through this complexity thing, because I think it might be easier to go through it first and then
Cool.
go to specific things. So the complexity of this specific function will be n, and this loop will execute that function of complexity n times. So the complexity will be n times n is n squared. And similarly, if this was some other function, which, let's say that other function has complexity square root of n. Well, the function of this entire sum function will be n times square root of n is n times square root of n. You can't further simplify this. And that will be the complexity of this function. Now, there's something else to consider. Let's say we had some things we executed one after the other. So let's say this part is indeed complexity O n times square root of n. And let's say we add another loop over here. So let's say we do basically the same thing as over here, but this time we don't call this other function that has complexity square root of n. Well, you'd think that executing these one after another, they would get a higher complexity, right? Because first we execute this one, which has complexity O n times square root of n. And then we also execute this other one, which, since it loops over n times, will have complexity n. Well, the thing over here is that whenever you have this plus over here, whenever you add these complexities together, you can remove all of them except for the one that scales the most. Because for larger and larger and larger inputs, the effect of the smaller factors will become redundant. So this n times square root of n will be so much larger compared to this one that this one is not important. So you can remove any trivial factors. You can, for example, also have, well, let's say 5 is over here, or there's another square root of n over here. You can ignore all of those and only look at the largest one. So all of these you can simply remove. So you only look at the part of your program that scales the most with higher and higher inputs. Now, a thing that can happen is that over here you loop over something else. So let's say we also had an array over here. And we wanted to loop over that array as well. And we would do something with this. In that case, we would have two different inputs that both scale independently. So in this case, you would add them together. So the complexity of this one is wholly dependent on the length of the string, which we called n. And this one is dependent on the size of the array blah, which we can call something else. So let's say m. So in this case, you would keep them separated. And similarly, if we shuffled these around, you could get a complexity of n times m, where both of these are different factors that we can change around. What else? Okay, any scalars or any trivial factors can be removed. So complexity of 2n is not something you need to use. You can always remove these scalars away, because a complexity of O n is exactly the same as a complexity of O2n. So it's weird to put this notation in there, because they will scale exactly the same way. If the input for this one gets 2 times as large, it has the same effect as the input of this one getting 2 times as large. And similarly, if we have O n plus 25, that's not something you need to use, because this 25 gets trivial when input get larger and larger and larger, so we can remove this 25. Any other things? Well, I guess I can do recursive things, but let's get to questions for now. Shema, what questions do we have? Shema?
Sorry, I missed that. What did you say, the questions?
Yeah, questions.
Okay, so let's see. The first question is from Laura, and she says, also, Sparky said the answers to the exemplar exam will not be published. Do you know why? Because it feels a bit useless now, because you won't know whether you did it right or not.
Is that so?
I agree with her.
Yeah, I don't know. Sparky is sometimes very particular about things.
Can the TAs do something for the students? Because it's indeed very stupid.
I mean,
sorry.
I'm sure someone could upload the answers to the Cognac cloud. I don't really have the time to put that together, but I'm sure someone could.
Okay, I will ask around if I can get someone to make the exam and get correct answers. Okay, guys?
That doesn't seem very strange.
Last week, Paul sent the answers. I think how
I won't promise, but I will try to get someone, and I'll just look them very nicely in the eyes and ask if they can do that, and then I will post it somewhere, and then you guys can use it. Okay, the next question is from Mirta, and she says, can a function without a parameter have a complexity different from O1?
Well, yes and no.
I think I have the answers. Last year, I remember Paul T, the current T, he sent answers last year, and I have them.
So the basic idea is that there needs to be something that scales to have a complexity. So generally, with a function that will be the parameter on it, but like you could also say that let's say there's some list hard coded in here. So let's say blah was not a parameter of this function, but it was instead. Can you maybe mute yourself, Shema, because I can hear Abbas in the background. Thank you. So let's say this was a hard-coded function that said like some input here. Then in some sense, you would say that this function has a complexity based on the input size of this, but like generally it's you need to have something that scales in order to have a complexity. So yes, maybe they can give you an example where it's not a parameter, but there needs to be something that's interchangeable, that can have a different size. And whether that's something hard-coded or with a parameter, I don't know. But in any implementations, like hard coding is not really a thing. So the complexity would be like based on some parameter that you get to your function. Let's see. Any other questions on complexity?
Yes. So another question is from Robin, and he asked, or she, I don't know. But why is looping through the characters of a string a higher complexity ON than just printing out the string, which is O1? Because the string is just an array of chars, which you can loop over when printing it, right?
Right. Yes. That is correct. Yes. Okay, so technically maybe that would have a different complexity, but the thing is, generally you don't work with very, very, very large strings. The important part is that you can assume all of these functions that you generally use to be of complexity O1, and I think the string might have some internal thing that makes it like quicker to print it out, but it's not really the important part. The important part is that when you loop over something, you look at how that thing scales, and that is the complexity you add to it.
Okay. Another question. Laura is asking, is there a moment where we would need to keep in the trivial parts?
No, never. You can always remove them because they are identical to the. Well, okay, there is something in the sense that if you have multiple different inputs, so for example, one thing scales with the size of a string, or one thing scales with the size of one list, and something else scales with the size of another list, then you could have something like n squared plus m, where these are both independent factors that can scale like independently of each other. But these would not be trivial terms. Like a trivial term would be something like plus n over here, where it gets overshadowed by this n squared. So you can just simply remove that, or you can remove a scalar that you have on this m because it's logically equivalent to not having it. Any other questions?
Yes. Another question is, wait, let me see. Yeah, Sophie is asking, so for the complexity of the function with the array and string as parameters, the complexity was n times square root of n plus m,
Right.
or did you have to ignore the m because the other part is bigger?
For the part that I was doing before, that was why did I remove that stuff? Yeah, you didn't have to ignore the m part because the m part was a separate thing. So the length of the complexity of this loop is dependent on the size of this array, while the complexity of this loop is dependent on the size of this string. So they were separate factors that you like. I think on the test you will only get things with one factor, but just in case I'll add these in because I think they are part of the course material. So yes, you would have the complexity of this loop, which was dependent on n, and the complexity of this loop, which was dependent on m, so you would both keep them in.
Okay. And then Merit is asking, how can you get a complexity of O square root of n or something like that?
Oh, well, let's say, let's remove all this. Let's say we have this list blah, and we want to only loop over subsection of it. I think there was a good example of it in one of the assignments, but I don't really have one, so I'll give a stupid example. So let's say we wanted to loop only through this list until a certain point. So int I is 0, I is smaller than, and we only want to loop until we get to the square root of blah dot length, and then I plus plus. Need to import this. So this would be an example which has a complexity square root of n, just because for this loop, whenever the size of the array, blah, gets 2 times as big, the thing loops until square root of 2 times as high. So because the length of this loop is correlates to the square root of the length of the list. So if the length of the list increases, then the number of iterations of the loop will increase proportional to the square root of that length increase. So this would be a way in which this happens. So yeah, that.
Okay, cool. Thank you. And then the last question that I see here is from Jesse, and Jesse is asking, that was something on the slides about complexity halving, like halving, whatever, and the complexity becoming O2 log n. But how does this work? And when do you have to halve something?
Okay, yeah, I think the specific thing was about the heap sort algorithm. So the thing over there is, how do I put this in a nice way? Okay, yeah, let's say you have some the interesting about the heap thing about the heap sort algorithm is that you have something in a tree shape basically. So you have some thing over here, something over here. So let's say there's some number over here, and then those again split off into further parts. So you have this tree, and the thing over there was that the complexity of heap sort turns out to be something with a logarithm. And so why is that? Well, the thing is, the number of steps you need to take to walk through this tree, it's dependent on the logarithm, second base logarithm of the size of the tree, because each time we go to the tree, we split in two. So half of the tree is on this side, half of the tree is on that side. So what that turns out to mean is that the number of steps you have to take to get from like the top of the tree to this leaf node is equal to like the branching factor, which is 2, and the size of the tree, which is 8 in this case. And that means that the complexity will compute to an annotation of the 2 log of 8, which is equal to 3. And as you can see, this actually works because we take 3 steps to get over here. And similarly, if we branched off further, so if we went over here and had another layer of this, it would be 16. And then we would go to complexity of 4. So that's basically where this thing is coming from, very simply put, because it doesn't compute exactly to this. But it's basically the way logarithms work is just swapping around the exponent and the what's that called? Well, you basically want to get to the base number. You want to get the exponent from the base and the total number of things you get out of it. So to do that, you use logarithms, and this tree structure in particular tends to have these logarithmic complexities when you have to loop over these things where you take these steps from these leaf nodes to these root nodes. So that's the basic idea of it. I don't think I explained it very well, but I hope it helps somewhat. Any other questions on complexity?
No, there are no other questions anymore. And by the way, a little announcement. I got the answers for the practice exam, so I will see if I can put them on the study cloud, but I will also share them in a group.
You're the best.
Thanks.
So, yeah, maybe I'll also briefly touch on recursion and complexity. So, if there are...
Oh, wait, 1 second. I see one more question. I didn't see that. Robin is asking, so O2 log n is the opposite of 2 to the power of n, right?
Yes. Well, opposite. Well, there are 3 numbers in any basically triplet of... so basically you have this 2 to the power 3 is 8, and then you can write that into the third base square root of of 8 is equal to 2, and similarly the 2 log 8 is equal to 3. So these are it's basically the triplet of things of how you can convert these things to each other. So that's where that thing comes from. 2 is the branching factor in this case, and over here, let's say it's something else, is the size of the tree, and that's why you can compute to this to get to the number of steps you need to take to walk that tree.
Okay. And I see one more thing, and that's Mirte, and she's asking if there is a way to practice complexity.
I assume there's like practice things for it online. If you want, I can do a quick check on that after I finish the tutorial and send it to you.
Okay. That's cool.
Okay, let's see. Oh yeah, recursion. So if there aren't any calls to functions with higher complexity, then if a function only calls itself once, so let's say we have this recursive function over here, and it has some parameter, let's say m. Then if it directly calls itself and just reduces this factor to 1, then the complexity will be linear. So let's say we have something like this, then the complexity of this will be O, and because it's basically identical to how you would loop through, go through a loop. Like if you had want to print something out here, you would loop through this n times. So the complexity of that is equal to that of a basic for loop. Like this comes in a lot of forms. It's not only with like these integers which decrease. You could also, for example, have a list which you go through, and whenever you have an element, you look at the next element and go to it that way. Or like a string that continually goes through its characters and does something based on that. Now, if you have multiple calls inside of a recursive function, so let's say we had another recursive call over here, and it also decreased by 1, then we would have complexity 2 to the power n. Now, where does this come from? Well, each recursive call here, if you think back to the tree from before, creates 2 instances of itself. So there will be 2 things for the first input size. There will be 4 for the second one, 8 for the next one, etc. Until you get to the layer where it actually gets to the base case and terminates itself. So since it doubles every time for these 2 calls, the complexity also doubles every time for the call. So that's why this 2 to the power n is the complexity that it takes on. And similarly, if you had a direct tail recursion over here with 3 calls, then it would become 3 to the power n, etc. So that's where these powers come from. Any other questions on this complexity? Because otherwise I think I will move on to recursion in general.
I don't see any questions anymore. Oh wait, one person typed now. Sophie's asking, so it does not matter for the complexity what you do with the n in the recursion? So yes, whether you do n something or n times something?
Well, it depends. Like if you have a recursive function and you do something else inside of here, so let's say there's a for loop inside of here, and that has some other complexity, then it will scale with this the complexity of this for loop. Or similarly, if you call another function, and that has some complexity, then you will again have to multiply the complexity of that function with the complexity of the recursive function. And then you might, in this case, get something like the complexity of the other function times the complexity of this function, which is O 2 to the power n. And whatever this computes out to be will modify the complexity of this.
Okay. I think those were all the questions. So yeah, we can move on.
Okay. I think I'll move on to... Oh, nope, not there yet. So what was I at? Was it 6? Yeah. Okay, so what is recursion? Recursion is a function that calls itself either directly or indirectly or through a lot of other functions, but this is the basic gist. You have a function that calls itself. Now, recursive functions are always functions that have parameters, or that at least have some kind of thing that changes, because otherwise, if it calls itself once, it would always call itself. So there needs to be some point at which the function stops calling itself. So we call that the base case, or the base cases. Those are the cases in which the function does not call itself. The other cases, the ones in which the function does call itself, are called the recursive cases. Often, when you are writing a recursive function, the base case is a good place to start, because there's some point in your program at which the function should stop, or at which a solution is found, or at which no other paths can be explored. Those are the things that you need to consider the base cases, and for which you need to write a termination, basically. So a lot of things that you can do with iterative functions, you can also do with recursive functions. So let's say we wanted to print this 1 to 4 vertically. Well, we could do that using a loop, obviously, but we could also do it using a recursive call. So if we execute this code, let's hope this works. Okay, yes. You'll see that it consecutively prints out the numbers in this thing. Let's look at how it does this. So first, what is the base case over here? Well, the base case is the one where it doesn't call itself, so that's this one. So if n is smaller than 10, then it will print out the digit itself. If not, then it will print first the reduced thing of this. Like it will pass this part to another function, and it will print out this one. So that's why this works. Now there's two kind of ways you can do this. There's tail recursion and left recursion. Tail recursion is where the recursive part is at the end of your function. So that would be having your print word over here. That would print this out in reverse. So 4 to 1 instead of 1 to 4. And you can have left first recursion. So where the output is given on the right side and the recursive cases go on the left. So that this would be an example of that. Now for recursive functions, they can be direct or they can be indirect. So for example, an indirect example would be if we extracted this as a different method. Oh. Maybe I'm doing something wrong here. Let's do it like this. So let's say we had some method over here, which is called from this function. So inside of this function, print vert is never called directly, but inside of the function that's called inside of that function, it is called. So this is called indirect recursion, where you get back to this function through some other function. And there's a lot of things you can do with this kind of thing. You can like it's basically the idea of what you have had with formal reasoning, where in some cases a problem basically consists of smaller versions of itself, and you can get to those versions by recursively calling them. So that would be, for example, with search problems, depth first search is generally easiest to implement through recursion. And there are many other examples of this. Shem, are there maybe already questions on recursion?
What do you exactly mean?
Are there already questions on this?
Oh, sorry. Let me check. No, I don't see any questions on recursion yet.
Okay. So one thing you can do with recursion is calling multiple times inside of the same function. So let's say I have another method over here where I again call myself. Well, via the other function in this case, but you know. So let's take a look at what's actually happening here. So first off, it gets the main function is executed. It executes this printthird function. It's not yet smaller than 10, so it will move to this recursive case. First, this one is executed. That goes to these three. So these 1, 2, 1 are printed. Then the 4 is printed through this system.out.print line over here. Then again, the same yeah function is called, and that again goes to this case. First prints out the 1 through another printthird call, then goes again to this system.out.print line, prints out the 2, then goes back to the yeah over here and prints out this one. So this is an example of multiple recursion in one function, where it calls multiple instances of itself, perhaps with different parameters. So for example, we could also have this one be different from this one and have some thing there which computes something. So this is the basic idea of recursion, functions calling themselves to get to simpler solutions of a problem. Any questions on this, Shema? Shema?
Yeah, so, yeah, sorry, I was browsing through the tabs. Someone is asking, Laura's asking, what does this function do again? I don't really understand.
Oh, well, yeah, it's not really the clearest function. So initially this function printed out an integer in a vertical way. So it printed these things from top to bottom. So what it would do was when you give it an integer 1 to 4, it will print 1 to 4 from top to bottom. Wait, did I mess something up here? Let's do it like this. So where that is coming from is this modulo basically gives you the part that remains when you divide by 10. So for the first iteration of this, that would be 4, right? Because if you divide this by 10, then the remainder of that is 4. Then you pass the other part of it, this n divided by 10, which is 12, because when you divide integers in Java, it rounds down to the nearest integer. So if you divide 124 by 10, then it computes to 12. And you pass that again, and then it prints the last digit of that, which is 2. And then it passes the 1 again to this, and then it prints the last digit of that, which is 1. So that's the basic idea of what this function does. And then I added a whole bunch of stuff on it to show other stuff, but it's not really a function that you would be using in practice.
Okay.
Any other questions on recursion?
Yes, let me see. Yeah, there are quite some questions now. Yes is asking, so for multiple recursion, when it reaches the first call to itself, it just loops through that entirely until it reaches a base case, after which it will continue to do the other lines.
Exactly. So the way you could see this is in a multi-line thingy. First it calls the first function, then it calls some instance of itself. It does something over there, and then only when all of the things inside of that thing are executed, it will go back to this function. So if anything is still after this first call to itself, then first it will do all of the things inside of that thing, and then it will return to it. So this one might spark 2 instances. First one instance of this, go to everything over there. So let's say this one also creates 2 instances of itself. It will first do this one, then go back to this function. Then the other one will be recreated. He will do something over there. Then it will return to this one. Then finally, when this one is finished, it will return to this one, and only then will this start continuing its process and will go on to the next thing that it will create. So yeah, that's the idea. All of these functions first execute all of the stuff inside of their recursive calls before they go back to their parent calls. And this is also why recursive functions are particularly well suited for depth-first search problems. Because in breadth-first search, it doesn't really make sense to do recursive calls because, well, you always need to fully execute the recursive case before you get back to the other case.
Okay. And then Max is asking, how would we go from this recursive function to an iterative function?
This print vertical one, well, you do something like, okay, I'm going to do this in pseudocode because with integers it's maybe not as easy. Well, for example, you would say something like, what was the integer? 124. 124. Well, a lot of times the recursive functions correspond to something like a while loop, with the while condition being the base case. This while I is greater than 0, let's say. System.out.println I divided by 10, and then I divided by I equals I divided by 10. So this would be the iterative way of doing the same function. But recursion is particularly useful when you are using multiple recursion, because in that case there are often not as many easy iterative circuits for it. Like they do exist. There is a way to convert any recursive program to an iterative program, but it's often much easier to use recursive calls. Another question,
Okay.
Sienna.
Let's see. Another question is from Robin, and Robin is asking if you would visualize double recursion in a tree, is it the case that it prints things out depth first search, and every time the left node is the first recursion call and the right node is the second one?
Yes, that is correct. So basically, the thing it does is it's basically like if you had multiple functions in your main function, it would always execute the first one that you call first, right? Well, it's exactly the same inside of recursive functions. So the instance that will be executed first is the one that's called first. So if we had two recursive calls here, it would first go into this one, go through that entire thing until it gets to like all of the places where it terminates, then go back to here, and then it would go like execute some stuff over here, and then it would go into the other recursive call, and again it would execute all of the stuff over there until everything terminates, and then it would go back over here and go back into this recursive function. So yes, it's basically that first search where it always executes the first function that it comes across first.
Okay. And then CW is asking, can you explain what multiple recursion is again? I still don't get the difference.
A multiple recursion is just where a single a function calls multiple versions of itself inside of its body. So single recursion is where it only calls one version of itself, and it's not that much, not that different from just using a loop. And multiple recursion creates multiple instances of that same function from one function. Other questions?
Max is asking, does this function not print in reverse order when compared to the recursive function?
Oh yeah, maybe. Well, we could just put this one above the print statement and it would reverse the order. It's not that different. But yeah, there would also be a way to write it in reverse order.
Okay. I think that is everything. I also have one small thing because people were asking how they can practice with complexity. I just put together some stuff I found in a document. I sent it to you via Discord, Olaf. So if you can first check if it's still relevant for this year's course, because I don't know what exactly you guys do. But if it's relevant, then I will make sure to post that also in the group chat so that people can practice with those as well.
Yeah, sure. I'll do that after the
yeah
thingy, and then I'll
okay, cool.
I assume there will be something in the WhatsApp group about that. Yeah.
Yes. Cool.
Cool. Okay. Then is this enough for recursion? I don't know. It's like a lot of examples of it are very specific and might be harder to do so. If you still aren't clear on recursion, I suggest maybe dropping by in the Discord after the tutorial, so I can maybe talk you through some specific examples. Otherwise, we'll be moving on to the next topic now, which is okay, we're on 7. Oh yeah, a short thing on depth first search versus breadth first search and when and how to use them. So depth first search and breadth first search both have their uses. Generally, well, let me just list a few advantages to each. So for depth first search, it's useful when there are many solutions to multiple solutions to a problem, and you can reach any of them, and it doesn't really matter which solution you find. Um, it's also useful because it's very easy to implement it in a recursive way. Um, Meanwhile, breadth-first search um, is often useful when you want to find an optimal solution, where like an optimal solution is defined as one with the shortest path, or the shortest way to get to it. So if you remember the um, assignment of the last the last programming assignment, you had this thing where you had to find the shortest path to a specific place in a maze, and breadth first search is very useful for that, because any path it finds will automatically be its shortest path, because it always checks out all of the paths of a certain length before it gets to the path of the next length. Because let's say you're okay, imagine this is a grid. And you're trying to get from here to over here. Well, breadth first search will always go through these options iteratively. So it checks out this one. Then before it goes on and checks out other stuff from here, it will first check out the other options from the origin point. Only then it will move on to the thing you explored over here. Go out from there. And then finally, when you get to the goal node, you can like reason your way back from, okay, from this goal node, how did I get here? Well, I got here from over here, and then this one will say, okay, I got here from over here, and then you have automatically a shortest path to the goal. So that's the thing you did in the last assignment. An example of a depth first search problem would be like the coin problem you got the week before that. So where you have to get to some solution where a bunch of coins um, add up to a certain amount. And in that case, it's very useful to just loop through all of the possible combinations of coins and get to one where it matches the correct amount. So in that case, you would have a multiple recursion where from each of the nodes again, you have one root node where you either turn on or turn off one of the coins. Then you look at the next coin. You either put that one on or off, and you do that until you get to a place where your numbers add up. So these are some of the advantages and disadvantages of breadth first versus depth first search. Are there any questions on this, Jema?
Yes, I see one question, and that is from Laura. And Laura is asking about the search problems. Do we have to know the code to the coins and Sudoku problem, or were they just case studies?
There were case studies. You don't have to know those things by heart. What I can ask you is to implement a recursive function. And what I would recommend in that case is to just carefully think about first the base case. So first think about, okay, when do I stop my program? And then in the case of that first search, you figure out, okay, how can I systematically walk through all of these options? So I think in the case of Sudoku, the idea was that you have some recursive function that goes through each of the numbers. So you have the loop, goes through numbers 1 to 9. and it tries that specific number out for the next position. It gives that number, it gives a Sudoku, and then each Sudoku calls the next position and tries all of the numbers for that. So in essence, you're running through all of the possible combinations of numbers you can try out for Sudoku. But like, I don't think you will need to like fully implement anything this complex. But like they might ask you to implement a search problem or something that, but they'll could probably give you some kind of framework for it.
Okay, those were all the questions so far.
Okay. Wait, did I have anything else lined up? Let me see.
I see one more question appearing, and that is, so we just need to understand depth first search and breadth first search.
Yes, you need to understand how they work, and you need to have some idea of how you could implement them. So the idea that with depth first search, it's useful to use recursive functions, and with depth first search, it might be more useful to use a loop or to walk over and to keep track of, like you did with the maze example in the last exercise, to keep track of the parents of any state so that you can find your path back. But yeah, do make sure you have an understanding of both of these search strategies. Any other questions for now?
Nope, that's all.
Okay. Well, I think this is basically all I had prepared for today. So if you have any other questions, I'll be available on the Cognac Discord for, I don't know, at least the following half hour or so. So you can just come by, chat over there, ask your questions, ask for extra explanational stuff, anything else. You can also, if you don't have any questions, drop in and see if you know, you might learn something from other explanations. Some final hints I'd like to, or some final things I'd like to say is, do make sure you do the example exam on Brightspace, and it's nice that the answers are now also available, because generally it's very representative of what kind of things will actually be on the test. On the actual test, don't be afraid to write like wrong or incomplete code. Generally, like you will get at least a part of the points if you get part of the solution, or if you like get the essence of the answer. There's also something you can do with a lot of these where they specifically say, hey, you're allowed to use helper functions. What that means is that you can put like extra functions in there to help you in things. So one thing you can do, if you're not sure about how to do a certain part, is to just put a helper function over there. So let's say you have some problem and you're very sure about how to do this part, then just do this part. And then there's some part in between that you're not sure about, then you can just put a temporary function there. And then later, you can figure out how to actually implement that temporary function if you still have time to do so. So don't be afraid to put down temporary stuff. Don't be afraid to give answers. It's fine. Like specific syntax is not the most important thing. Thank you all for dropping by, and good luck on the exam. And maybe I'll see some of you on Discord after this. I hope so. Otherwise, also credits to Robbie for some of the examples I used. She's great. Shema's great. Good luck, everyone. think I'll end the stream here unless there are other questions, Shema.
I don't see any other questions. Thank you
Okay.
very much, Olaf, for doing this and putting in the effort and the time.
Yeah,
You're amazing as
welcome.
well. And yeah, have a great evening, all of you guys.
Yeah, good luck, everyone. I think I'll leave the stream open for a little bit longer, just in case the questions still come in. Otherwise, you can just drop by on Discord, and I'll handle your questions over there.
All right, I am gonna leave, guys. But yeah, good luck with everything. And oh yeah, Olaf, let me know if the questions are fine, which I send you like the complexity things.
Yeah,
and if they are fine, I will put them in the group and also hopefully on the study cloud.
Yep. Okay, thank you.
All right.
Bye-bye.
Evening, everyone. Bye.